Now, very important theorem, that is the remainder theorem for the chapter Factorization of Polynomials. This theorem is related to polynomials and the real number. What is this theorem? Remainder theorem states that if Px be a polynomial, we have any polynomial indicated by symbol Px of degree. If polynomial is there, it has degree. Here we are not taking case of the constant polynomial. Px be a polynomial of degree greater than or equal to 1. As mentioned here, if degree is greater than or equal to 1, it cannot be a constant polynomial. And a be any real number. A is any real number, may be rational or irrational. If this Px, that is the given polynomial, is divided by x minus a. Polynomial Px, when divided by x minus a, then the remainder is equal to P of a. This is the statement of the remainder theorem. Before I give you the proof, I just would like to tell you, I just would like to share with you one example. How? Let us suppose x square plus 4x minus 5. This is a polynomial. Let Px be a polynomial. So, x square plus 4x minus 5 is a polynomial. Degree greater than or equal to 1? Yes, degree of this polynomial is 2. A be any real number. Suppose I am taking 1 is any real number. 1. 1 is any real number. Answer of A is 1. Equal to, then real number, if Px is divided by, Px means this. This means x square plus 4x minus 5 is divided by x minus 1, meaning by x minus a is here what? X minus 1. So when this x minus 1 divides x square plus 4x minus 5, I am actually dividing it. You will notice it is x. This becomes x square minus x. So minus and plus get cancelled. Here it is what? X is taken, this becomes x square minus x. On subtracting, this is minus, this is plus, this gets cancelled, this becomes 5x minus 5. If it is 5x minus 5, then I am taking here 5. This becomes 5x minus 5. Now on changing, this becomes cancelled and 0. Remainder is 0. So this is actually, I have obtained the remainder 0 when I have performed actual division. So here Px was x square plus 4x minus 5, a was 1, x minus 1 divides x square plus 4x minus 5, remainder comes 1. As per this theorem, directly remainder can be obtained if Px be a polynomial of degree greater than or equal to 1 and a be any real number. If Px is divided by x minus a, then remainder is P of a. Here, what will be the answer of P of a? Here a is 1, so P of 1 is equals to 1 square plus 4 into 1 minus 5. So answer of P of 1 becomes 1 plus 4 minus 5. P of 1 is coming 5 minus 5. P of 1 is equal to 0. You can see remainder when question has been divided by divisor, then remainder is 0. And also actually as per theorem's statement, when it is put 1, because a is 1, then also remainder is 0. Px is the polynomial like x square minus x minus 3. And the number is what? Suppose I say number is what? 2. Number is 2. So if Px is x square minus x minus 3 and a is equal to 2. So a is equal to 2 means answer of P of 2. P of 2 becomes 2 square minus 2 minus 3, 4 minus 5 is what? Minus 1. P of 2 is minus 1. So I can say remainder when this polynomial x square minus x minus 3, will be divided by with the help of 2, divisor will be x minus 2, because if a is the number, then if a is any real number, then divided by x minus a. If 2 is any real number, then has to be divided by x minus 2. P of 2's answer is minus 1, that is the remainder. Now if I perform the division, actually what is the remainder? X minus 2, I will take x, this become x square minus 2x. X square minus 2x, then what will be this? Minus and plus. This will get cancelled. I will left with x minus 3. Now I will take what? Plus x. Then I will be what? X minus 2. Now minus and this plus get cancelled. Minus 3 plus 2, remainder is minus 1. So remainder is minus 1, and here value of P of 2 is minus 1. So both the cases we are saying yes, this is true, that if Px be a polynomial of degree greater than or equal to 1, a is any real number, then if Px is divided by x minus a, then without actual calculation we can say the remainder is P of a. Now the proof of this theorem is very simple. If I am taking Px is any polynomial, if Px is the polynomial and then I am dividing this by x minus a, because a is any real number. Suppose quotient is qx, then remainder is rx. But here remainder cannot be in the x, because the degree of remainder is always less than the degree of divisor. Here degree of divisor is 1, so remainder has to be only what? R. So this is Px is the dividend. Here the dividend is Px, the divisor is x minus a, the quotient is q of x, and the remainder is r. As per division algorithm, dividend formula is dividend is equal to divisor into quotient plus remainder. Here what is the dividend? Px is equal to what is the divisor? X minus a. What is the quotient? Qx. Then what is the remainder? Here r. So I can say, if I put if x is equal to a, if x is equal to a, then Px become P of a is equal to, in place of x a, this become a minus a into q of a plus r. A minus a is 0, 0 into q of a is 0, 0 plus r is r. So what is coming? P of a is equal to r. So that is what remainder is P of a. Here also remainder is P of a. So this verify the proof of the remainder theorem. Though for the examination of the point it is not so important, but you just can see how this remainder become P of a. Now I will explain you the use of the remainder theorem in solving the problem. Now I want to discuss with you an example based upon the remainder theorem. Find the remainder when polynomial Px is equal to x cube minus 6x square plus 2x minus 4 is divided by 3x minus 1. So with the help of this divisor 3x minus 1, I can say x is equal to 1 by 3. So now 3x minus 1 implies x is equal to 1 by 3. So remainder will be P of 1 by 3, that is x cube, meaning by 1 by 3 cube minus 6 into 1 by 3 square, 2 into 1 by 3 minus 4. So P of 1 by 3 is equal to 1 by 27 minus 6 by 9 plus 2 by 3 minus 4. So answer of this P of 1 by 3 by taking 27 as LCM, this become 1 minus 18 plus 18 minus this will be 108. So I can say this become minus 107 upon 27. So answer of P of 1 by 3 is minus 1 upon 7 upon 27. So you can conclude that when x cube minus 6x square plus 2x minus 4 will be divided by 3x minus 1, remainder has to be minus 107 upon 20. Now a bit lengthy question based upon remainder theorem. If Px is equals to x4 minus 2x cube plus 3x square minus ax plus b is a polynomial such that when it is divided by x minus 1 and x plus 1 with two different divisors, the remainders are 5 and 9. That is, when divided by x minus 1, remainder is 5, and when divided by x plus 1, remainder has to be 19. Find the remainder when Px is divided by x minus 2. So we must understand here that when the Px, that is Px when divided by x minus 1, first it is divided by x minus 1. In this case remainder is 5. So what implies this? That P of 1 is 5. X minus 1 become what? X is equals to 1. So P of 1 is 5. Px when divided by x plus 1, then the P of minus 1 is 19. So we will get two equations, and with the help of these two equations, first we will find A and B, and after finding A and B, we will find the remainder when the same polynomial is divided by x minus 2. So P of 1 is 5, meaning by in the polynomial, this polynomial is Px is equals to x4 minus 2x cube plus 3x square minus ax plus b. Put x equals to 1 because x minus 1 can be obtained, that is x equals to 1. So P of 1 is equals to 1 is to power 4 minus 2 into 1 whole cube plus 3 into 1 whole square minus a into 1 plus 1. But answer of P of 1 is 5. So this value is to be equated equal to 5. So this is 1, this is minus 2. 1 minus 2 plus 3 minus a plus b is equals to 5. Or I can tell you minus a plus b. Minus a plus b. I kept these two variables in the left side, and this becomes 3 plus 1 4. 4 minus 2 become 2. 2 when shifted become 3. So minus a plus b is what? 3. Or I can say a minus b is equals to minus 3, equation number. This is 3, this is 1, 4. 4 minus 2 is 2. When 2 is shifted become 3. I have changed here sign, so this become plus a, this become minus b, 3 become minus 3. First P of 1 is 5 gives us equation a minus b is minus 3. And in second situation, when the same polynomial is divided by x plus 1, what implies x plus 1? X equals to minus 1. So x equals to minus 1 means remainder is what? 19. So P of minus 1 is 19. So in place of every x, I have to put minus 1. P of minus 1 is equals to minus 1 is to power 4 minus 2 into minus 1 whole cube plus 3 into minus 1 whole square minus a into minus 1 plus b. So this become 1, this become plus 2, this become plus 3, this become plus a, this is plus b. But the result of P of minus 1 is 19, so this is equals to 19. Now what we can do, that is a plus b is equals to 3 plus 2 5 plus 1 6. When subtracted, I get 13. Equation number 2. If I ask you to add 1 and 2, so sum of 1 and 2 minus b and plus b will cancel. 2a is equal to positive 13 minus 3 will give us 10. So answer of A is 5. If A is equals to 5 is put in either equation, either in 1 or in 2. So if I put in 2, it will be 5 plus B is equals to 13. This implies B is equals to what? 8. So answers of A and B are 5 and 8. So the net polynomial will be, our Px will become what? X raised to the power 4 minus 2x cube plus 3x square minus a. A means what? 5. That is minus 5x plus b. B means what? 8. So the polynomial becomes this. Answer of Px becomes x raised to the power 4 minus what? minus 2x cube plus 3x square minus 5x plus 8. Now the question says, if this is the polynomial, when divided by x minus 1 remainder 5, x minus 1 remainder 5, x plus 1 remainder 19. With the help of these two conditions, I have obtained a and b and substituted in the polynomial. Now they want to find the remainder when same polynomial is divided by x minus 2. So what implies x minus 2? X minus 2 implies that x equal to 2. So remainder when the polynomial is divided by 2 will be x p of 2 is equal to 2 raised to the power 4 minus 2 into 2 cube plus 3 into 2 square minus 5 into 2 plus 8. So answer of p of 2, this is 16 minus 16 plus 3 3 are 9. Sorry, this is 2 2 are 4 3 are 12. This is minus 10 plus 8. 16 and 16 get cancelled. P of 2 become 12 minus 10. This is 2. 2 plus 8, 10. Hence the answer when this is divided by x minus 2, that is remainder has to be. Now I am talking to you about the last concept of the chapter, that is factor theorem. What is this? It's a type of remainder theorem. In remainder theorem there was a polynomial, there was a number. With the help of that number we obtain the divisor. When we divide by divisor we obtain the remainder. Here same way, let px be a polynomial of degree greater than or equal to 1. There is any polynomial whose degree is greater than or equal to 1. And a, this a be any real number such that, this is what kind of number? When this a is put in the polynomial, the result becomes 0, that is remainder becomes 0. So we say x minus a is the factor. And conversely, if there is a factor, there is a polynomial x minus a. If x minus a is a factor, then we say p of a is 0. So this is two way. That is what? If px is any polynomial, degree is greater than 1, a exists any such real number which when put in place of x, then polynomial becomes 0. Then we say x minus a is a factor. If the value of polynomial become 0 at x equals to minus a, then x plus a is a factor. And conversely, if x minus a is a factor of polynomial, then p of a will be 0. So this is the theorem which is known as the factor theorem. How I will apply? I am taking an example. Suppose px is any polynomial, that is x square plus 3x plus 2. And 1 is any number. I can take minus 1 is a number. So if I ask you what is p of minus 1, you say it is minus 1 whole square plus 3 into minus 1 plus 2. So answer of p of minus 1 become 1 minus 3 plus 2. Answer of p of minus 1 become what? 3 minus 3. P of minus 1 becomes 0. So a's role is being played by minus 1. A, b, any real number. Minus 1 is that real number. Polynomial is x square plus 3x plus 1. It is a polynomial of degree greater than 1. P of minus 1 is coming is 0. It means that as p of minus 1 is 0, what implies that? X plus 1. Because remainder is coming 0 at minus 1. So x plus 1 is a factor. Now in case the same question, if I ask you that if x plus 2 is its factor, I am taking converse result. That is conversely, if x minus a is a factor, then p of a is 0. If I say if x plus 2 is the factor, if x plus 2 is the factor, then what has to be? P of minus 2 has to be 0. That is what? P of minus 2 is equals to minus 2 whole square plus 3 into minus 2 plus 2. This becomes 4 minus 6 plus 2. You can say this is 4 plus 2 positive plus 6 minus 6, result is coming 0. So the factor theorem is applicable both ways. A, that is if some number is in such a way that on which the result becomes 0, the first condition, and the second, if factor is given, then on that particular value so obtained, the answer of polynomial has to be 0. Now the question is based upon the factor theorem. So that x plus 1 and 2x minus 3 are factors of px polynomial 2x cube minus 9x square plus x plus 12. To check whether x plus 1 is its factor, to check x plus 1 is its factor, what has to be x plus 1 implies x equals to minus 1 and remainder is p of minus 1. If this becomes 0, then we say yes, x plus 1 is a factor. So we will trace the value of p of minus 1. X plus 1 is a factor. X plus 1 will be factor only if value of x so obtained, that is x plus 1 implies when plus 1 is transferred, x equals to minus 1. So on x equals to minus 1, remainder of this polynomial should be 0. Value should be 0. This becomes 2 into minus 1 whole cube minus 9 into minus 1 whole square plus of minus 1 plus of 12. This becomes 2 plus 9 minus of what? This 1 plus of 12. So I can say this result become here minus 1 square is plus, so this is minus. So I can say this is minus 1 whole cube will be minus 2. Minus 2, minus 9, minus 1. This become what? Minus 12 plus 12, result is 0. So p of minus 1 is coming 0. We can say yes, p of minus 1 is 0, meaning by x plus 1 is its factor. For the second case, 2x minus 3. 2x minus 3 implies that x equal to 3 by 2. So I will check is p of 3 by 2 0. If p of 3 by 2 becomes 0, then I can say yes, it is the factor. It is means 2x minus 3 is the factor of 2x cube minus 9x square plus x plus 12. So to find p of 3 by 2, put 3 by 2 in place of x. So p of 3 by 2 become 2 into 3 by 2 whole cube minus 9 into 3 by 2 whole square plus what? 3 by 2 plus of 12. That is what in place of every x is replaced by 3 by 2. This becomes 2 into 27 by 8 minus 9 into 9 by 4 plus 3 by 2 plus 12. So if I solve it by taking LCM as 8, I will find it is 54. Then minus 9 9 ja 81 into 2 162. Then plus of this is what? 4 4 3 ja 12. This is what? 12 upon 1 96. So this answer is coming 0 by 8, that is equals to 0, as p of 3 by 2 is 0. So I can say that 2x minus 3 is its factor. P of minus 1 is 0 says x plus 1 is factor. P of 3 by 2 0 says 2x minus 3 is a factor. Hence this question is verified. Now one very easy application of the factor theorem. Determine the value of a. We need to calculate the value of a for which the polynomial 2x4 minus ax cube plus 4x square plus 2x plus 1 is divisible by 1 minus 2x. Divisible by 1 minus 2x means 1 minus 2x is the factor. As 1 minus 2x is the factor, so by factor theorem, what we can say that 1 minus 2x implies x equal to half. Meaning of this that p of half in the polynomial will be 0. That is remainder by putting x equal to half has to be 0. So this becomes 2 into half raised to the power 4 minus a into half of cube plus 4 into half of square plus 2 into half plus 1 is equals to 0. In this polynomial, every x is replaced by half because 1 minus 2x is factor. 1 minus 2x implies x equals to half. So I can say this becomes 2 upon 16 minus a upon 8 plus 4 upon 4 plus 2 upon 2 plus 1 is equals to 0. If you simplify this, you will get a is equals to 25. Because by taking LCM and simplification, you can calculate a. So the answer of a is what? 25. Now one problem where both the theorems, remainder and factor, will be applicable. If ax cube plus bx square plus x minus 6 has x plus 2 as a factor, means x plus 2 is a factor, means when this is divided by x plus 2, remainder is 0. And leaves remainder 4. It leaves remainder 4 when divided by x minus 2, then what are the values of a and b? As x plus 2 is a factor. As x plus 2 is a factor, so this implies p of minus 2 has to be 0. So I will put minus 2 in place of x and is equals to 0. This becomes a into minus 2 cube plus b into minus 2 whole square plus of minus 2 minus 6 is equal to 0. Minus 8a then plus 4b minus 8 is equal to 0, relation number 1. And leaves remainder 4 when divided by x minus 2. X minus 2 implies is x equal to 2, and leaving remainder 4 means p of 2 is 4 by factor theorem and here by remainder theorem. So if I put 2, this will be a into 2 whole cube plus b into 2 whole square plus 2 minus 6 is equals to 4. So this will be what? 8a plus 4b. 8a plus 4b is equals to 8 because minus 2 plus 4 minus 4 transferred here 8. If I ask you to solve these two equations 1 and 2, I will get a is equals to 0 and b is equals to 2. So in same question we can apply both the theorems. Now one more type of problem, that is using factor theorem, factorize the polynomial x cube minus 6x square plus 11x minus 6. So we will think some numbers on which this can be 0 and on which numbers it will be 0. With the help of that I can trace the factor. So for this, first of all we will go to factorize. We will find the prime factorization of the last digit, and if any digit is written here with their product. Here it is 6. For 6, which numbers can divide? Plus 1, minus 1, plus 2, minus 2, plus 3, minus 3. First of all, I will see and I will put x equals to 1. If x equals to 1, then this polynomial will be p of 1 is equals to 1 cube minus 6 into 1 square plus 11 into 1 minus 6. This becomes 1 minus 6 plus 11 minus 6 become 12 minus 12 become 0. P of 1 is 0. This implies by the factor theorem x minus 1 is its factor. If x minus 1 is factor of this, suppose in case if it is not coming 0, then we will try for minus 1, then plus 2, then minus 2, then plus 3, then minus 3. It will come 0 on one of the factor, and whatever number will become factor. Suppose plus 1 is not a factor, minus 1 become factor, then we will say as p of minus 1 is 0, then x plus 1 is factor. If it is 0 on 2, then we will say x minus 2 is a factor. If it is 0 on minus 2, then it is x plus 2 is a factor. If it is 0 on plus 3, it is x minus 3 is a factor. Now x minus 1, I will take to divide the polynomial x cube minus 6x square plus 11x minus 6. Here first is x square, x cube minus x square minus plus cancel, this left with minus 5x square plus 11x, then minus 5x, this become minus 5x square plus 5x, then plus and minus, I left with 6x minus 6. I will take 6, then 6x minus 6, minus and this. Now I have obtained this. Factors of x square minus 5x plus 6 with the help of splitting middle term x minus 2 into x minus 3. So all three factors become, first factor is x minus 1 and other two factors are x minus 2 into x minus 3. So this is the way of asking what is a factor theorem, what is a remainder theorem, what are their uses, how we apply, what actually ways of asking for the factors as discussed in this last question. Similarly, there may be infinite number of problems which you can just wind up and can get confidence only and only while you are practicing, while actually you are doing by your hand on the piece of the